Now let's suppose that we invest $1 at 100% interest for 1 year. So that means in our compound interest formula, P, R, and T are all going to equal 1. Which means our compound interest formula becomes A equals P is just 1 times 1 plus R is 1 over N to the N times T is 1. So we're just left with 1 plus 1 over N, all raised to the nth power. Now if this $1 at its 100% interest is compounded annually, that means that N is just 1, and plugging 1 into this formula in place of N gives us a value of A equal to 2. Quarterly means that N is equal to 4, and when we plug a 4 in place of this formula, in place of the N, we end up with approximately 2.4414 for A. Monthly means N is 12, and when we plug a 12 in this formula in place of N, we get a value for A of approximately 2.6130. Compounded daily, meaning N is 365, this gives us a value for A of 2.7146. Hourly, so that would be 365 times 24 would be 8,760 times a year. And when we plug that in place of N, we get 2.7181 for A. Every minute, so that would be the 8760 times 60 minutes in an hour, would give us 525,600, so 525,600 times per year. And plugging that in place of N gives us 2.7183 for A. And let's do one more. Every second. So when we take the 525,600 and multiply it by 60, since there's 60 seconds in a minute, we get 315,36000. So that's how many times the interest would be compounded per year. And then plugging that into the formula in place of N, gives us approximately 2.7183 again for A. So you would think as N continues to get bigger and bigger, A would also continue to get bigger and bigger. But it seems like A is actually leveling off somewhere around 2.72. And in fact, if we let N go off to infinity, so just let it continue to get bigger and bigger and bigger, which is what we call compounding continuously, A gets closer and closer to this number that we call E, which is approximately 2.7182, and so on and so forth. And while it might look like just some random irrational number, it actually shows up in a lot of real-life applications. Not just compound interest, but also biology and other areas, which is why it gets its own special symbol, just like pi gets its own special symbol. So we call this number E. And this is located on your calculator. Again, if you're using the TI-30X, the E to the X is located above the LN button. So if I hit second and then that ln button, I'll get e with an exponent, and then I can plug in whatever number I need to, whatever I'm trying to evaluate for a given problem. So then if we are told that our interest is being compounded continuously as opposed to some other time frame per year, then our compound interest formula actually becomes A equals P times e to the RT. And this is again where P is the principal, R is the interest rate as a decimal, T is time in years, and then E is this number that's approximately equal to 2.72. So we want to use the compound interest formula to approximate the final value of $100 at 1.5% compounded continuously for 50 years. So here is the key word that tells me I'm going to use this formula as opposed to the other compound interest formula. So I need to identify P, the principal, that is the $100. R is the 1.5% converted to a decimal, which would be 0.015. And then T, the time in years, is 50. And I'm just going to take those values and plug them into this formula. So A equals P is 100 times e to the R is 0.015 times T is 50. So then to get that into my calculator, I'm going to start with the 100, and then I'll hit the second ln to get the e and the exponent, and then I'll plug in the exponent of 0.015 times 50. Close parentheses, hit equals, and we get approximately $211.70.